Okay, young world conquerors. Here's what we're doing today. Unit 2, Video 2. Notes Video 2. We got a couple learning targets. One, you can find slope and rate of change. The other is you can write a linear equation. So a little bit going on here today. We're going to start out with slope. Generally, the grade of a road is the percent that measures the steepness of the road. It is found by dividing the amount the road rises by the corresponding horizontal distance. So the rise of the road compared to horizontal distance, or sometimes we call this run. You're going to hear me talk about slope. M is your variable for slope. And working with rise over run. Okay. Slope of a line is the ratio of the change in the y-coordinate to the x-coordinate. The formula for it, a couple of different ways we look at it. If you have this point, x sub 1, y sub 1. And we'll call this point over here x sub 2, y sub 2. Two ordered pair points. The slope, or in this case m, equals your change in y over your change in x. And this is where we make most of our mistakes. We get the x's on top and the y's on bottom. It's always change in y first. The formula they're probably used to is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Right there. A lot of times you'll just hear me say change in y over change in x. Or, we'll get to that in a minute. But you subtract the y values, you subtract the x values, and you should have a fraction. A little bit about slope here. Parallel lines have the same slope. That represents parallel lines. If two lines are parallel, they have the same slope. So if these two lines here are parallel, if the bottom line has a slope of 2, the top line would also have a slope of 2. Now, the contradiction to that is perpendicular lines, or the opposite, I should say, of that. Perpendicular lines have slopes that are opposite. If one's positive, the other one has to be negative. The reciprocals of each other. Reciprocals is where you just take a fraction and flip the numerator and denominator around. So, let's say the slope of one line is negative 3/4. A perpendicular line, there's a symbol for perpendicular. Perpendicular slope to that would be, well, this one's negative, so this one over here is going to be positive, and then the reciprocal. You flip the 3 and 4 around, so it'd be positive 4/3. So if one slope is 1/5, a perpendicular slope to that would be negative, first of all, because the first one's positive, and then 5/1, or just negative 5. So that's a little bit with perpendicular slopes. Okay. One other thing. One thing you should know is when you're traveling to the right on the XY axis, if your line is going up, as this one is going up, your slope is positive. Over here, as we're going to the right, you can see your line is going down. That is always going to have a negative slope. Then you have your horizontal and vertical lines. If it's a horizontal line, your slope is a 0. And if it's a vertical line, it's undefined. That slope is undefined. Okay. We're going to find some slopes right now. Let's give ourselves a little room. Given two ordered pair points, find the slope of a line that passes through these 2 points. All I said slope is, I'm going to say change in y over change in x. Little triangles are actually the symbol for delta. This is delta y over delta x. Another name for it is change in y over change in x. It's just a little shorthand is all it is. So change in y over change in x. So that's negative 2 minus 4 all over 1 minus negative 1. Here are my y values. They always go on top when you're finding slope. I started with this one, this y value, y coordinate, so I have to start with the corresponding x value. That's why I have 1 minus the negative 1. So working with this, negative 2 minus 4 is negative 6. That's the same as plus a negative 4. Negative 2 and negative 4 add up to negative 6. Double slash here, we get plus a positive. So that is 2. And my slope is negative 3. A lot of people like to write as a fraction negative 3 over 1. Either one of those would be fine with me. Over here, same thing. Slope equals change in y over change in x. So my y values are the same. 2 minus 2, which is going to give us 0. And then 3 minus a negative 3. Now, plus a positive, this is going to give me 0 over 6. So is my answer 0 or undefined? This would just be 0. If you had something, I don't care what it is, we'll say 7 over 0, you cannot divide by 0. So this would be undefined. This is an example of a horizontal line. This would be an example of a vertical line. Okay, graphing some lines. Some students struggle with this. This should be pretty easy. This is no different than graphing it when it's in slope-intercept form. You're given a y-intercept and a slope, you can graph. Here we're given a point and the slope, and you can graph this just as easily. First you graph the point 2, negative 1. Over 2, down a negative 1. So there's my point on the line. Now slope, that 1/2, is the same as rise over run. So I'm going to rise up 1 and run 2. Rise up 1, run 2. Or you could do just the opposite, down 1, back 2. Now, does my graph make sense? Well, my slope is positive. So my line, as I'm going to the right, should be going up, and it is. So this is a perfect example of graphing a line with a positive slope. Over here, this slope is negative. So first of all, graphing the point, negative 3, 1, 2, 3, down, negative 1, 2, 3, 4. You graph the point that they give you that the line goes through, and then kick in the slope. Now here, it's negative 3 over 1. That's rise over run. And some people, when they see the negative, they think rise and run are both negative. If your slope is negative, only one of them can be negative. Because if it was negative 1 down here, negative 3 divided by negative 1 is a positive 3. And we don't want that. So if slope is negative, only your rise or only your run can be negative. They can't both be negative. So down 3, 1, 2, 3, over a positive 1. So many people go down 3 and back 1, and that's wrong. Can't do that. The opposite of negative 3 over 1 is positive 3, 1, 2, 3, and negative 1. And this is what my line should look like. And as I go to the right, it should be going down because it is a negative slope, and it is. So we graphed it correctly. Rate of change. Rate of change is basically the same thing as slope. It measures how much a quantity changes on average relative to another quantity, often time. In this case, my time is day. So this is like my x, and the height depends on the day. So this is my dependent variable, and this is my independent variable. If you want to describe them as x and y. You could find your average rate of change for the plant's growth per day using slope, change in y over change in x, and just pick a couple of these ordered pairs. I'm just going to do this. From this day to this day, the first day that they started keeping track basically to the last day that we have on this chart. I want to find height per day. So height is going to go on top. In other words, change in y over change in x. So 10.5 minus 6 all over 5 minus 2. And I'm going to get 4.5 divided by 3. If you plug this into your calculator, you should get 1.5. And that's centimeters per day. Centimeters per day. It's growing. What is the starting height of the plant for the plant? Now, you would think it would be 0, right? Well, I'm going to go to day 0. So if day 2, it's 6, right here, it's 6 centimeters tall. How tall is it on day 1 and how tall is it on day 0, our starting day? Well, 6 minus 1.5 is 4.5. 4.5 minus 1.5 is 3. So the day they started measuring this plant, it was 3 centimeters tall. So the starting height, I guess, of the plant would be 3. Although 0 makes sense to me, but according to day 0, when they start measuring it, it is 3. It says, write a linear model that represents the height of a plant after D days. Well, I guess the height, we'll call it H, equals, every day it's growing 1.5 centimeters. So I'd say 1.5 times the number of days would be its height. Now when you plug 2 in there, you should get 6. When I plug 2 in for D, 2 times 1.5 is 3. I'm missing 3 centimeters. Oh, that's this 3 right here, the original that we started out with. So I have to add 3 onto it. So the height equals 1.5 times the number of days plus 3 from the original starting point where they started measuring the plant. Okay, another rate of change here. Kevin's savings account changed from $1,140 in January to $1,450 in April. So find the average rate of change per month. January, February, March, April, that's 4 months. So I guess I would look at it this way. 1,450 minus 1,140 divided by however many months you're working with, and that would be 4 in this case. So 1,450 minus 1,140 is 310, and we're dividing it by 4. So let's grab our calculator here. Handy dandy little TI. Well, it's not working for me. Well, if you divide it, you should get $77.50. $77.50 per month. It's going down. Okay. Slope-intercept form of a linear equation. We talked about slope-intercept form, and that's y equals mx plus b. B is my y-intercept, and m is my slope. But we're going to write linear equations, and I want you to write them in, put them in slope-intercept form. But we're going to start out with a little shortcut. I think it's a little bit easier, and we're going to write them in point slope form first. Point slope form is this. If you're given some point, I'll say x sub 1, y sub 1. Some point. And the slope, point slope form is basically this. Y minus y sub 1 equals m times x minus x sub 1. Now really, the only thing you're plugging in here, first of all, is the slope, m. And that's going to be coming from right there. The other thing that we're going to be working with is you're going to plug in x sub 1 and y sub 1. And that comes from this point that you're given right here, x sub 1 and y sub 1. And if you're given 2 points, usually you just plug in the first point, but it really doesn't matter. This is the original x and y that you're working with, that you're going to leave in the equation when you rewrite it in slope-intercept form. So this is slope-intercept form, makes sense because you're given the slope and the y-intercept. Point-slope form, you're given a point right here, and you're given the slope, whatever that is in this case. So, types of equation we'll write, given a slope and a point, you're going to use point-slope form. And this is basically what we just copied down over here in green and black. So let's try number 5. It says write an equation in slope-intercept form for a line that has a slope of negative 2/3 and it goes through the point negative 1, 4. This is your x sub 1 and y sub 1 right here. So y minus y sub 1 equals m times x minus x sub 1. This is point slope form first. That's what we're going to plug it into. Then we can rewrite it into slope-intercept form. Basically, point slope form and slope-intercept form are just different ways of writing the same linear equation. So y minus y sub 1. So we do plug in a y sub 1, and that is 1 in this case. Our slope, negative 3 halves. X, we don't plug anything for that. We plug it in for x sub 1 right here, and that's negative 4. First thing I would do is say this is plus a positive 4. So if I want it in point slope form, there it is. Y minus 1 equals negative 3 halves times the quantity, x plus 4. But what I really want you to do is translate this into slope-intercept form now. And that's very easy. You basically just solve for y. Whenever you want it in slope-intercept form, you solve for y. So first of all, multiply through by the negative 3 halves to get rid of your parentheses. So y minus 1 equals negative 3 halves x. Negative 3 halves times x is just negative 3 halves x. And negative 3 halves times 4 is going to be negative. There we go. Some people get a little mixed up with the fractions. I'm multiplying negative 3 halves times 4. You can simply do this on your calculator. You have to use parentheses for the fraction. So I'm going to hit parentheses here. It's negative 3 halves. You can't hit minus. You have to hit the little negative button down here. 3 divided by 2 and the parentheses. I'm multiplying it by 4, so times 4, and then just hit enter. Negative 6. So there it is. Negative 6. Last thing, I'm going to add 1 to both sides because we want to get that y by itself. Y equals, now it's solved for y, negative 3 halves x plus, negative 6, and positive 1 is going to give me negative 5. There it is. Here it is in point slope form, and then we rewrite it in slope-intercept form. Okay. You guys come back and look at this if you want. Let's go up here. And now we want to do number 6. Given 2 points. First, find the slope and plug that slope and point into point slope form and rewrite your equation in slope-intercept form. Hey, if they give us 2 points, you can just say, hey, this is x sub 1, y sub 1. You can say this is x sub 2, y sub 2 if you want, because we have to use that in order to find slope. But then you just go from there. So let's move this down and give ourselves a little bit of room. I have my point, my x sub 1, y sub 1, is negative 1 and 4. I'm going to decide that right away. I do need my slope. Slope is change in y over change in x. So I'm going to say 5 minus 4, those are my y values, and negative 4 minus negative 1. 5 minus 4 is 1. This is plus a positive. This is going to give me a negative 3 or negative 1/3. I always write the negative in the top or just to the side of it. So my slope is negative 1/3. Now I can put it in point slope form. This is going to give you y minus 4 equals negative 1/3 times x minus negative 1. This is plus a positive, and there it is. This is point slope form, but I want to write it in slope intercept form when I get done. So I am going to say y minus 4 equals negative 1/3 x. Well, negative 1/3 times positive 1 is just negative 1/3. The only thing I have left to do here is add 4 to both sides. And I get y equals negative 1/3 x, plus 3 2/3. You could plug this into your calculator again and say 4 plus a negative 1/3. You'd get a decimal. It would be 3.6666667, so 3.7. These two numbers are the exact same thing, just one is written as a fraction, one is written as a decimal. I would take either answer on a test or a quiz. So there we go. Once again, if you want to look at this again, just rewind it. Let's pull up number 7 here. It says write an equation in slope-intercept form for a line that is parallel to y equals 3x plus 1 and passes through 2, 3. Okay, first thing, I have my point. X sub 1, y sub 1 is the 2, 3. So we have that. We need the slope. And all they give us, the only other thing they give us is y equals 3x plus 1. Well, we're saying our line, the equation of the line that we want to write, is parallel to this line. The slope of this line, it's solved for y, so it's in slope-intercept form, is m equals 3. So if it's parallel to our line, our slope is also going to equal 3. A lot of people try to use the 1 here. No, the only thing you're getting from this equation is basically the slope. Your y-intercept is going to come from this. Y minus y sub 1 equals m times x minus x sub 1. Every time you write a linear equation, you should write this little formula down. To begin with anyway, it'll help you memorize point slope form. So this is all I need, right here and right here. I don't need this y-intercept here. I don't need to add or subtract anything to it. Some people try to do more than they need to do. So y minus 3 equals 3 times x minus 2. There we go. We're done. It's in point slope form. But I also want you to write it in slope intercept form. So you're going to solve for y. Just solve for y. So get rid of the parentheses. Y minus 3 equals 3x minus 6. Add 3 to both sides. Y equals 3x, in this case, minus 3. Negative 6 plus positive 3 is negative 3. And we're good. This one can get a little bit tricky, but it's basically the same thing that we just did. It says, as a salesperson, Eric is paid a daily salary plus commission. When his sales are $1,000, he makes $100. When his sales are $1,400, he makes $120. So he has sales, and he has how much money he makes. how much money he makes depends on his sales. So I would say this, the sales are your independent variable. That would be X. And how much you make depend on your sales. That's Y. So this is the independent variable, and this is the dependent variable. So if you're looking at ordered pairs and writing a linear equation to model this situation, 1,100, my X and Y, and 1,400 and 120, my other X and Y. Well, I'll do this. We'll call this X sub 1 and Y sub 1. The only thing you're missing is the slope, so we have to find the slope. Change in Y over change in X, and we're just going to use the two ordered pairs. So 120 minus 100 over 1,400 minus 1,000. This gives us 20 all over 400. If you reduce that, that's 1/20th. If you plug this into your calculator and divide it and get the decimal, it's 0.05. You could do the 1/20th or the 0.05. I really don't care. I'm going to use the 1/20th for right now. So Y minus Y sub 1 equals M times X minus X sub 1. Y minus, I said Y sub 1 is 100. 1/20th. X minus 1,000. That's my X sub 1. And then we're just going to put it in slope-intercept form. So that's 1/20th X minus 1/20th on your calculator times 1,000 is going to give us 50. So that's negative 50. Oops, I put equals here. That's Y minus 100. So we just do this. Add 100 to both sides. And we're going to end up with Y equals 1/20th X plus 50. Negative 50 plus a positive 100 is going to give me positive 50. So you could use this little equation to make predictions, like what if you had a $5,000 sales day? Well, that'd be Y equals 1/20th times X is your independent variable. That's your sales, so that's 5,000 plus 50. I'll let you do that on your calculator. You can try that out and see what you get. And I will see you guys tomorrow. Peace out, Girl Scout.